Hey class, so today I wanted to go over section 3.4 because I know one or possibly a few of you weren't there in person. So in 3.4 we talked about slope and rate of change. And here are the objectives. I'll let you read them for yourself. But basically, in summation, what we're looking at is if we have a graph of a line, what quantity in its linear equation tells us how that graph changes. So for any input x, how does that change our y, like the output? And it's actually not as complicated as you may think. So if we first just talk about something called the slope of a line, the slope is just how it changes. And the slope is just kind of like we use it in our everyday lexicon, like the slope of a hill, the slope of a mountain, whatever it is. It's just talking about the steepness between, the ground and the top of the mountain, right? Except now we're talking about linear equations when we graph them. And the way that you calculate this is we call this the rise over run. Good way to remember it, rise over 1, where the rise is going to be our change in y here, and the run is our change in x. So that's why we call it rise over run, because this is kind of a rising action, and this is kind of like a run along, or like run just makes more sense with it. Anyway, so if we wanted to calculate some function's change, some function's slope, we would just simply do y2 minus y1 over x2 minus x1. And something I like to point out is we can actually swap these labels. We could call this point x2 and y2, and this point x1 and y1. So it doesn't actually matter which point gets the first coordinates and which point gets the second coordinates. All that matters is that we keep these consistent. So these have to be both either the 1 or both the 2 coordinates. We can't have a point having y1 and x2, for example. They have to have the same subscript. But that's enough of me talking. We can actually look at an example. So here's an example of what I'm talking about. We want to find the slope of this line, and we're given 2 points on the line. So as you see written or typed out here, we took one coordinate, called it x1 and y1, and then we took the second coordinate to be x2 and y2. And then we simply subtracted the y's, divided it by the subtraction between the x's. And to prove the point that I was trying to make earlier, we can make this now x1 and y1, and we can make these x2 and y2. And then we can see if we get the same result. So our y2 is -3, and our y1 is 2, so -3 minus 2. And then our x2 is 4, and our x1 is 2. So now we do this, and we have -5 over 2. And as you see, we get the same exact thing, because remember that it doesn't matter where the negative is in a fraction, because -5/2 is the same as -5 over 2, and that's the same as 5 over -2. So here we get the same slope. But now let's get to an example where you can figure this out yourself. So here in our notes, let's just do the slope between the coordinates -1, 5 and 0, 0. So again, just to walk you through this example, we do m, oops, okay, here we are. So what I was saying was, again, we can just do m is equal to y2, we can just make these our 2 coordinates. So 0 minus y1, 5. Then we have x2, which is 0, minus x1, which is negative 1. So here we get a negative 5 divided by, this negative is going to cancel with that, so we get a positive 1, meaning our slope is negative 5. So go ahead and try to solve b on your own, and why don't you go ahead and pause the video now and try to do that. Okay, hopefully you went ahead and paused the video and you found that your answer was that the slope was equal to negative 1. Okay, let's move on. So before, in our 2 examples above, we got negative slopes, and you might be wondering what that is. And here we can talk about kind of the rise of a run again. So remember that m, the slope of it, was the rise of your graph divided by the run of the graph. And here notice that we went in the positive direction in the y when we did our rise, and we did a positive direction in the x when we did our run, right? Whereas if we're over here on our negative slope, if we do a positive rise, we have to do a negative run to get back to our slope. So we have to go positive, and then we have to go negative. So here we see kind of an intuitive example of why these slopes are positive and negative. Because since we're doing a division here, we have a positive divided by a positive, which is just some positive number or positive fraction. Whereas here we're doing a positive divided by a negative, which is going to give us a negative number or a negative fraction. So this is kind of why we say, or not why we say, this is why these lines are positive and negative slope. And you can simply remember this by looking at each line and reading it from left to right. So as you read it from left to right, is your y increasing or is it decreasing? Right? Notice that when you go left to right here, your y is increasing. Whereas with the negative slope, when you go left here, your y is actually decreasing. So those are 2 kind of ways that you can remember this. But let's move on. So in example 2, we want to find the slope of the line through these points, and then we also want to graph the line. So first, let's go ahead and find the slope. So here we're going to do 4 minus a negative 2. And we're going to do a 2 minus a negative 1. So then here we get 6 divided by 3. Now again, I do want to emphasize that it's up to you which one you choose as your second or first coordinate. Just keep those labels consistent. So we have a slope of 2, and that tells us it's going to be a positive graph. So our line should be going in this motion. So let's check that. We'll do negative 1, negative 2, and then we'll do 2, positive 4. So right here. And then graphing this line as straight as I can. There we go. That is our line with the slope of 2. So go ahead and do B on your own and pause the video. I'll get back to you. Okay, so here's the solution for example 2B. We have a slope of 1/3 and our line looks like this. One thing to take away from this pair of examples is both of these lines have a positive slope. However, notice that here we have a fractional slope and our graph really isn't that steep. Whereas in this example, we had a slope of 2, right? A slope that's greater than 1, and notice how steep our graph became because of that. So the higher the number is, the more steep your graph is, or your line is. Okay. So here, in example 3, we have a table and we have ordered pairs. So these are solutions to a linear equation, and we want to find the slope of the graph here. So again, I want you to pause the video, try to find a way to solve this. And it's not going to take anything that you haven't seen already to solve this. So just try to think it out for a second, and I'll get back to you. Okay, so I didn't solve this completely because I kind of wanted to highlight what knowledge you needed to use in order to solve this. So remember that because these are ordered pair solutions, I can pick out these ordered pairs right here, which just come from the table. And these are going to be points on the line of this equation. So we can then just write these as ordered pairs and use the slope formula that we've already used before. And in this example, we'd get 7 minus 2 divided by -1 minus 0. And here we would find 5 divided by -1, which is going to give us a slope of -5. Okay, so now we're going to talk about a different form of linear equations. So you might be familiar with this form, we just haven't really given it a name, right? We were always kind of writing equations in terms of y, but here we're going to formalize this form and call it the slope-intercept form. The reason why it's called the slope-intercept form is this m that we've been solving for is going to appear as the number multiplying your x. So that is the slope. That is the same m that we've been solving for above. And the y-intercept should be fairly intuitive, but just imagine that we put 0 in for x. And now what do we have? Well, this goes to 0. So then we just get y is equal to b. And remember, this is exactly what we did when we found the y-intercept of a linear equation. So here we have the y-intercept and just an example to kind of show you what this looks like when there's numbers in terms of these variables. We have this equation here. So y equals 2/3 x minus 5. The m is going to just be this 2/3. And the y-intercept is going to be 0, -5. Okay, so I'll do part A for these examples, and then you go ahead and do part B. So here in part A, we simply get that the m is going to be 3/4, and our y-intercept is going to be 0, 6. Okay, so I'm going to move on to 5 and 6a, and then I'll pause the video and you should try to do 4b and 5 and 6b. Okay, so in 5a, what you have to do is you have to rearrange this equation. So what we're going to do first is we're going to subtract 5x on both sides of this equation. So that way these cancel out. So this 5x, and we're left with simply y is equal to -5x plus 2. So our slope is then m is equal to -5, and the y-intercept is 0, 2. That's how you deal with those types. So I'm going to pause the video now and go ahead and try to solve part B. Okay, and this is, or these are the solutions to part B of each of these examples. Hopefully you were able to figure these out. The only things I kind of want to highlight are be careful of your negatives, so make sure that your negatives are going with you in your solutions. Notice the -4 and -5 there. And the second thing that I want to point out is your m. So never put this as improper fraction, or as mixed number. So never put your m as a mixed number. Always put it, for example, as 7 over 4 or 14 over 3 or something like that. Don't write these as mixed numbers. And also, never put this as, I shouldn't say never, but do not put this as point, what is this, 75, unless told to. So the problem will say round to the nearest decimal, or the nearest tenth, sorry, or to the nearest hundredth. Unless you're told to write something as a decimal place or to round to a certain decimal place, you're always going to put your slopes as an improper fraction. So just wanted to really highlight that point. Okay, so we can move on now, and we can talk about horizontal and vertical lines. So here, this might be hard to grasp at first, just because of the nature of how kind of this may seem in your head at first. So we're really kind of programmed to see anything y as being vertical, right? So seeing this y equals -4, you might not automatically assume, okay, this is a horizontal line. But you have to think about it in this way. Since we're saying y is equal to -4, that means no matter what your input is to this function, whether it's x equals -6 or x equals -8, you're always going to end up at y equals -4. So you're never going to change in this vertical direction, right? And because you never change in this vertical direction, if we then talk about the slope of this, right, there is no rise. There is no rise in this horizontal line. So since there's no rise, that means when we do m equals, right, just to kind of hammer this on top of the head, we're always going to have -4 as our y. So that means we're going to have a 0 on the numerator. We do not rise on this function. So since that is the case, no matter what x2 minus x1 is, we're going to have a 0 up here, and 0 divided by any number is 0. Therefore, the slope of all horizontal lines is 0. That'll always be the case. And similarly, we can talk about the vertical lines. So again, this might be hard to remember, but just the x, even though it always, shouldn't say always, even though x is typically associated with the horizontal axis, because x is stuck in this position, no matter what our y is, we're always going to end up at x equals -7 in this case. So in a similar fashion, we can talk about the slope and rise over run. And in this case, we have a really big rise, or we could get a really big rise between two different points. But we can't, we get a 0 run, right? We don't move anywhere in the direction of run. So if we look at our slope formula m, right, we'll get some y2 minus y1. We'll have some rise, but as far as x2 minus x1, that'll always be -7 minus a -7, sorry, minus a -7. And that'll always give us a 0 on the bottom. And as all of you recall, whenever you divide a number by 0, what winds up happening is this number is undefined, right? Because we can't divide anything by 0. Remember, this all boils down to the simple fact that 0 does not have a reciprocal. And since 0 doesn't have a reciprocal, we can't divide by 0. So that means the slope of all vertical lines is undefined. And those are simple proofs for that fact. So moving on, we can then talk about, questions like these that will show up on MyMathLab. And I want you to just try to solve these on your own. Pause the video. Yeah. Okay, so hopefully you didn't just back the video up and look at the definitions above. But yeah, these are the answers to it. So remember that y equals will always give you, or sorry, y equals a number will always give you a 0 slope, and x equals a number will always give you an undefined slope. So the next thing we're going to talk about is parallel and perpendicular lines. So parallel lines are lines that have the same slope. So remember that the examples where we had m equals 2 and m equals 1/3, this is like the first couple examples we did. I said notice how 2 looks like this. It was pretty steep, whereas 1/3 was pretty shallow. Well, no matter what the formulas were for these lines, if we changed the second m to 2, then it would have the same exact steepness that the first example had. And this is always the case. If two m's equal, if two lines have the same slope, then they're going to be parallel to one another. The tricky situation is perpendicular lines. So in perpendicular lines, we have the negative reciprocal. So that means if two lines are perpendicular to each other, and one line has a slope m equal to a over b, and we could even give it as solid numbers. So just think about it in terms of solid numbers. So let's say we had a line with a slope of 2 again, right? We wanted to know what perpendicular, or what the slope of a perpendicular line was. Well, all we would have to do is take the negative reciprocal of this. So let me just remind you that we can write any number as that number divided by 1. So 2 is the same thing as 2 divided by 1. And now you should be able to see that the reciprocal to this is going to be 1/2. Now we do is stick a negative out in front of it. So these two lines would be perpendicular to each other, regardless of what b was. So yeah, that's all I have to say for now. We can look at some examples of parallel lines. And this is kind of what I was saying, just kind of drawn out if you wanted to see these. Okay. And before we get into an example, or example 9, I can just highlight this for a second. So what it's saying here is that all vertical lines are parallel to each other. All horizontal lines are parallel to each other. And so vertical lines are parallel to each other, but also the vertical lines are parallel to the to the y-axis. So all vertical lines are parallel to the y-axis. All horizontal lines are parallel to the x-axis. And a horizontal and vertical line are perpendicular always, because remember the x and y axes are perpendicular to each other. Okay, so here again I'm going to go through example A, then I want you to pause the video and do example B and C on your own. So example A, first of all we want to determine whether each pair of lines is parallel, perpendicular, or neither, just like we discussed a second ago. So here I'll call this M1 for this first line right here. M1 should be fairly obvious to you. M1 is just -5, just what's in front of the x. So for M2, I'm going to have to rearrange this a little bit so we can subtract x over on both sides and get -5 equals -x plus 10. Then we want to divide both sides by -5. And we're left with y is equal to 1/5 plus 10. 1/5 x, sorry. So this M2 is equal to 1/5. And hopefully you notice that 1/5 is the negative reciprocal of -5, right? Because remember, this is 5 over 1, sorry, -5 over 1. And the reciprocal to this would be -1 over 5. And to get the negative reciprocal, we just change the sign, so this becomes a positive. So just to emphasize, in example A, these are parallel lines. Okay, so go ahead, pause the video, and do B and C. Okay, so before I get into B and C, I just wanted to highlight that I did make a mistake here. I meant to write perpendicular. So perpendicular lines are lines where the slopes are negative reciprocals of each other. Okay, so in B, you should have found that these were neither perpendicular or parallel. And in part C, you should have found that these were parallel lines. So if you did not get these as solutions, double check that your arithmetic or algebra, I should say, was correct in the pairs of equations here. Okay, so I believe example 10 is something that I wanted to get to, but I was not able to get to in class, so we don't have to worry about example 10 or example 11. The only thing I want to highlight is, oh, okay, never mind. So this is the end of this section, and then I'll make a video tomorrow about 3.5. So hope this was helpful, guys, and I'll see you in class later.